Hello again and welcome to the VK6CS amateur radio channel. I'm just going to finish off that bit with the audio compressor, because it's not really amateur radio related, but it's an electronics project that some people might find interesting, and if you're getting into amateur radio you might enjoy building one or two electronic kits. Now this is the stereo compressor that I showed you. That it's an Altronics kit, and I've fired it up and actually used it on the on my hi-fi system. I did say that I'd fire it up on the air, but I couldn't wait. I was just impatient. So it was built. So I got a little power supply plug pack, plugged it into the wall, plugged it into this, and plugged it into the system, and away it went. And it certainly does what it says on the can. You can go from channel to channel without the deafening difference that you get usually on channel 73 here in Perth. It's very loud, and some of the commercials are very loud, and it's certainly ironed those bumps out. Now one thing that did happen to this was when I got home from work yesterday, it was dead, and I thought, no. And what had happened was this 10 ohm resistor here had gone open circuit, R1, and ZD1 here, Zener diode, had gone short. See if it will focus on that. Will it focus on that? The original ZD1 was the same colour as ZD2, sort of silver colour, and that's an orange one that I bought today and fitted today. Because what actually happened was, hang on a sec, and there's the two components I removed. As you can see, they're looking pretty sorry for themselves. That 10 ohm and that Zener. So the ZD1 went short, and the 10 ohm resistor, small half watt 10 ohm resistor, just burnt out to protect the device, which is what it's supposed to do. So that worked a treat. On the circuit diagram, these components are, that's R1, the 10 ohm, and that's ZD1 there, the 15 volt Zener. So this Zener went short, that's a ground connection, chassis connection, and this, not surprisingly, half watt resistor 10 ohm just burnt out, and it protected the compressor. Because what had happened was my little power supply, my little plug pack power supply, we had some really bad weather yesterday, and I suspect we might have got a lightning ping, because it was a 12 volt supply, and the output had gone up to a bit over 20 volts, and of course the Zener just clamped that down, and the resistor burnt out. But anyway, the components are replaced, so is the power supply. I've got a better quality power supply running the unit now, and I thought it might be interesting just to have a quick look at what it does. Now I'm putting in, see if I can zoom in on these meters here a bit. There we go. So I'm putting in a 1 kilohertz tone. You can probably hear it in the background, not very loud, but there it is. So I'm putting in a 1 kilohertz tone into the right channel at the moment. Actually, the levels on the two channels are slightly different, but not enough to worry about. Okay, so I've got 0 dBm going in, and I've set the output level there to neg 10. Okay, so if I, with a 2-to-1 compression ratio, if I increase the level by in by 1, I should get a 0.5 change on the output. So let's go up to plus 1 dBm. Okay, and of course the signal, remember this is a negative number, so the smaller the number the bigger the signal. So it's gone from neg 10 to neg 9.5. So the input has changed by 1 dB and the output has changed by 0.5 dB. And there's Al. Spot on time, 5 to 4. Marvellous. I'll just turn that off.
Hey Kevin, how you going? Geez, I spent about the last...
It's always the way. Unbelievable. Right. That's my fault there for not turning the radio off. Okay, so where was I? Right. So I've increased the input by 1 dB, and the output's increased by 0.5. Okay, so I'll go up to 2. Okay, so that's 2 dB bigger, and we've got neg 8.9 there. So the signal's gone up by 1.1 dB. So for an input level change of 2, it's gone up about 1. So that's still looking good for our 2-to-1 compression ratio. If we go up to 4, so now I'm putting in plus 4 dB, plus 4 dBm, and getting out minus 8.1. Okay, so there's a change of 4 there, and there's an output change there of plus 8 minus 8.1 output level. So we started with neg 10, so it's gone up by plus 1.9. Okay, so we'll call it 2 just to make it simple, because it's so close that you wouldn't detect it by ear. So we've gone up input plus 4, output's gone up by plus 2. It's gone from neg 10 to neg 8. So that's still looking good for our 2-to-1 compression ratio. I haven't looked at the distortion, but it certainly sounds okay on the hi-fi. I might look at the distortion in another video. I'll see how enthusiastic I feel about that one. Because if it looks really bad, I'll be disappointed. But I think for what it cost, I mean, it's only a budget thing, you know, it's not like a professional piece of equipment. I reckon it's doing a pretty good job. So we go to 6, plus 6. And then we got minus 7.8. Okay, so that's actually better than 2.1, isn't it? Because I would have expected that to give neg 7, and it's actually giving a neg 7.8. So that's actually keeping that nice and compressed. So we've got an increase there of only sort of plus 2.2 for an input change of plus 6. Now you might find a professional radio station compressor will do plus or minus 6 and give you 0 out. This is not a professional piece of equipment. This is just something that you could use to iron out the bumps in the audio levels on your hi-fi or your surround sound system, you know, if you've got your television running through it. Okay, so that's plus 6. So if we go back down to 0, there we go, gone back to neg 10 here. Let's see how it does with the smaller signals. So if we go to minus 1, it's gone to neg 10.6. So again, we've got about half a dB change for a 1 dB change in input. Go to 2, and that's gone to neg 11.1. So we've dropped the signal 2 there, and the signal's dropped by 1.1 there. So it's still about 2-to-1. Go to 4. There we go, 4 dBm going in, and we've got neg 12.3 coming out. So it's dropped by 2.3 for a drop in input of neg 4. So that's still about 2-to-1. And if we go to 6, neg 6, and we've got neg 13.4. So for a drop in input level of 6 dB, we're getting a drop in output level of 3.4. So that's about 50% as well. That's still about 2-to-1, isn't it? So really, for a little budget compressor, I think that's working quite well. Reset it to 0, got the neg 10 output, which is our reference level. I had followed the instructions and put a 0 dBm signal in at 1 kilohertz, and then I put my multimeter on the test points exactly as it says in the instructions, set VR1 to 1.8 volts, and then carried out this test. So that all looks quite good. So that's quite promising. I'll just show you the test setup. I'll zoom out a bit. And of course it's the wrong way. It had to be, didn't it, really? So basically I've got the 2 test units plugged into a Chrome block here. I just got an ordinary stereo phono lead, cut it in half and terminated that onto my chrome block here, the test lead interface block, and they just go around and plug in to the compressor. So that's the test configuration. It's pretty simple, nothing too elaborate, but it's just a simple way of showing that you know, input level versus output level. It does pretty much what it says on the in the instructions, or on the tin. So there we are. I'll put that back together now and put that back in line on my television surround sound system, and not have to worry about all those nasty loud commercials. Oh me, I'll just leave you with that final look at the two test gadgets. Well, I hope you found that interesting or informative, or both, and as always, thanks for watching. I'll catch you next time.